Right, so now I have a solid sketch here. The solid sketch has a diameter of 40 millimeter. Determine the absolute maximum shear stress and sketch a torque diagram. So they ask for maximum shear stress and torque diagram. So pertama sekali kita kena pecahkan dulu dia punya torque, by each section. So the first one is for TAB. For TAB stress is first we have to determine dia punya positive or negative. So for counterclockwise, I assume as positive, whereas the clockwise I assume as negative. So for here, for TAB, dia punya stress is negative 15 Newton meter to counter the positive one. And then for TBC, since it is at the same direction, so we just plus it, and we get negative 40 Newton meter. And then for CD, it's negative 40, and for 30 Newton meter it is as a positive axis, so we have to plus it. So negative 40 plus 30, we get negative 10 Newton meter. And lastly, for DE, we can see here that 50 Newton meter, 25 Newton meter, and 60 Newton meter is at the same direction. So plus it, we get 100, but then we have to counter it back with 30 here, so we get 70. But since 70 over here is at negative, so it's at positive, it's at positive, so we have to give it as a negative as the stress. Okay, so we got 15, negative 15, negative 40, negative 10, and negative 70. And for maximum shear stress in this diagram, we have to use the formula T R over J. Okay, so the T is at 70, even though the maximum is at negative. Since we have to find the maximum, we have to give it a positive value, and then the radius, we divide it by 20. And then for J, we use the formula pi over 2, and then we use 40. But since 20 and 40 is at millimeter, we have to convert it to meter. So we have to convert it. So that gives us 557,023.00, and we have to convert it to megapascal, so 5.57 megapascal. Okay, next one is for the torque diagram. Given that we already find the shear stress for each cutout, so we can just follow the values here. So starting from A is negative 15, so our point it will be around here. Alright, and then the second one, BC, is negative 40, and then we go down here. And then for CD we go up again. We go up again at -10. Go up again at -10 or around there. And then lastly, for DE, we go to -70. We go for -70, so it is around here. And then we complete the graph. So the shape will be like this. Thank you. Okay, so for the second question, knowing that the internal diameter of the hollow shaft shown is D equals to 38 mm, determine the maximum shearing stress caused by a torque of magnitude T equals to 2 kN per meter. Okay, so it is shown here that there are two diameters. The hollow one is shown to have 38 mm, whereas the second one is 80 mm. Okay, so for the first one, I will say D0 for the outer layer, which is 80 mm, or if we convert it, it will become 0.08 meter. And then for the hollow one, D1 is 38 mm, converted it to become 0.038 meters. Okay, so to find the maximum shearing stress, we use the formula T equals to TR divided by J, but before that we have to find the J. So to find J, given that there are two diameters, so we have to use this following formula, which is pi D0 minus to D1 and then divided by 32. So from here we can just to the power of 4. So following this formula, we can simply put it as shown: 0.08 to the power of 4 and 0.038 to the power of 4 as well, and then divided by 32. That gives us a final answer of 4.008 to the power of 10 -5, and since we convert it to meters, so the unit will be in meter cube. Okay, so following here, we can find the maximum shearing stress for this whole shaft. So the formula is as follow, and then we simply put it first. The T is in kilonewton, so 2 to the power of 10 to the power of 10 3, and then the R, the radius, should be the outer layer, so 0.04, and the J we just copy it here, so 4.008. Okay, so that gives us the maximum. That gives us the. So this gives us 1.996 megapascal.